Hello everyone. Today we're going to consider a problem that teaches us about the pressure in hydraulic systems. So let's start by reading the question together. The hydraulic system shown in the figure is in equilibrium. A. Find the height difference H between the two pistons. Okay, so we have to find this height difference between two pistons for given configuration. B. If one of the weights is removed from each side, what will be the new height difference in terms of H? So now we're going to remove one piston, one weight here, another weight from this side, and we have to find the new height difference and express it in terms of the H that we found in part A. C. If two of the weights are removed from each side, what will be the new height difference in terms of H? Okay, so now instead of removing one, we're going to remove two weights and two weights from here, and we have to express the new height difference in terms of the H that we found in A. Okay, before we start, let's recall what pressure is. Pressure is force per unit area. And since this system is in equilibrium, pressure 1, which is this side, has to be equal to pressure 2, which is this side, right? So because things are in equilibrium, so pressure exerted here and pressure exerted here are equal. So what is the pressure exerted on this side? Well, it's pressure from these weights, which is 3P divided by 2A, which is the area of the piston, plus P naught, which is atmospheric pressure, because the top of the piston is open, right? So you have atmospheric pressure also pushing here. This has to be equal to pressure on this side, which is 4P divided by area of the piston, which is 3A. Now, you also have a column of the liquid, and pressure exerted by the column of the liquid is rho GH, right? Density of the liquid times gravitational acceleration times height of the column of the liquid, plus P naught, which is an atmospheric pressure. Here, P naught cancels out. We move 4P over 3A to the other side and calculate what rho GH is, and it works out to be P over 6A. And now if we're going to solve it for H, it's going to be P over 6 rho GHA, right? So this is the answer for part A. So we found H in terms of weight and area and the density of the liquid. So what I'm going to do here, even though it's not a part of the question, I'm going to try to identify what is the density of the liquid. So I'm going to here just rewrite this equality such that I have rho here. And I get rho equals P over 6HG A. And we will need this later. That's what I'm doing here. Okay? So let's look at part B of this question. Now, if you're going to remove one weight from each side, so we still have this equation, but instead of 3P, now I have 2P, and instead of 4P, I have 3P, right? So because we removed one weight from this side, one weight from this side. And again, atmospheric pressures cancel out, and 3P over 3A equals 2P over 2A, right? Because these are essentially P over A, P over A. So this also cancels out. So I end up with rho GHB, and HB here is the height for the part B of the question. Okay, so I'm just using this notation. It has to be equal to 0. Now, that means HB is 0. So there is going to be no height difference. These two pistons are going to be at the same level. And that's the answer for part B. Now, let's look at the part C. Again, it's the same equation as here, but we're going to remove 2P. So if I remove 2P from here, it's just going to become P. And if I remove 2P from here, it's just going to become 2P. And P over 2A and 2P over 3A. And everything else same. Just instead of H, I'm going to use H sub C, meaning height for the part C of the question. Okay, so that's just the notation I'm using. Again, P naught cancels out. I move it to the other side, and I have rho GHC equals P over 2A minus 2P over 3A. And if we work this thing out, it's going to be minus P over 6A. And if you recall, we calculated what rho was in terms of the H, A, and P. So for rho, I'm going to put this thing in here. So I have P over 6HGA times G here and times HC. Well, PP cancels out because from both sides, A cancels out, 6 cancels out, and I end up with essentially HC over H equals -1, right? So everything cancels out. A, G, P, 6. So HC equals -1, or HC equals negative H. Negative height that was originally given in part A, right? So that means now this side will sink lower than this side by amount of H that we found here. So this side is gonna be lower by the same amount as it was in part A, but instead of now being higher, it's gonna be lower. And that's the answer for part C. And I hope this question is clear to everyone, and thank you.